Ever gaze upon a majestic mountain and wonder, how did this natural wonder come to be? Mountains, those towering giants that pierce the skies, have long held a fascination that transcends cultures and borders. Their majestic peaks and imposing sizes inspire awe, offering us a humbling reminder of our place in the grand scheme of things. They are not only stunning to look at, but they also play a crucial role in our world, serving as the backbone of ecosystems, influencing weather patterns, and even shaping cultures. But have you ever stopped to consider how these natural wonders came to be? It's a question that has captivated humanity for centuries. From the ancient Greeks attributing their existence to the mighty Titans, to modern geologists unraveling the complex processes that give rise to these formidable landforms, the mystery of mountains continues to intrigue us. There are several types of mountains, each with its own unique story of formation. Some are born from the violent eruptions of volcanoes, their fiery birth leaving a permanent mark on the landscape. Others are the result of the slow but relentless forces of erosion, their forms carved out by the patient hands of time and weather. And then there are those that rise from the depths of the earth, pushed upwards by the colossal forces at play beneath our feet. These are the fold mountains, the highest and most dramatic of our planet's peaks. Think of the Himalayas in Nepal, home to the world's tallest mountain, Mount Everest. These towering giants didn't just appear overnight. Their formation is a story millions of years in the making, a tale of tectonic plates and geological processes that is still unfolding even today. So, next time you find yourself gazing up at a towering peak or marveling at a mountain range's rugged beauty, remember that there's a fascinating story behind its existence, a story that we are about to dive into. So let's unravel the mystery behind the formation of these towering giants. To understand the birth of mountains, we must first delve into the structure of the Earth. Let's imagine Earth as an apple. Just as an apple has a skin, the Earth too has a thin outer layer called the crust. This crust, though, is much more complex than the skin of an apple. It's broken up into large pieces known as tectonic plates. Now, these aren't static. They're constantly moving, albeit at a pace slower than a snail's crawl, fueled by the heat from the Earth's core. The Earth's crust is divided into two types: the thicker, older continental crust that makes up our continents, and the thinner, younger oceanic crust that forms the ocean floor. These two types of crust behave differently when they interact, leading to a variety of geological phenomena. Now, imagine these tectonic plates as giant puzzle pieces floating on the semi-fluid layer of the Earth's mantle. Over millions of years, these plates move, collide, slide past each other, or pull apart. And it's these movements that are responsible for shaping the world as we know it today. When these plates collide, the impact can cause the crust to crumple and fold, much like a rug when you push it against a wall. This process is known as orogeny, and it's the primary force behind the creation of mountain ranges. In other instances, when an oceanic plate collides with a continental plate, the denser oceanic plate is forced under the lighter continental plate, a process known as subduction. This can lead to the formation of deep ocean trenches and volcanic activity. And sometimes, when plates slide past each other, they can cause earthquakes. This slipping and sliding is most noticeable at fault lines, like the infamous San Andreas Fault in California. It's a fascinating, slow dance of colossal proportions, a dance that has been going on for billions of years and continues to this day. Now that we've set the stage, it's time to see the action. The birth of a mountain is a tale of collision and pressure, a battle between the Earth's tectonic plates. Our planet is like a giant jigsaw puzzle, where the pieces are constantly moving, albeit at a pace slower than a snail's crawl. These pieces, known as tectonic plates, make up the Earth's crust and upper mantle, and their movement is the driving force behind the Earth's most dramatic geological events. Now, let's talk about plate tectonics, the theory that explains how these large pieces of the Earth's crust move and interact. Imagine two of these plates moving towards each other. What happens? Much like two cars in a head-on collision, they can't both occupy the same space. One must give way. This process, known as subduction, sees the denser plate forced down into the mantle beneath the lighter one. However, if both plates have similar densities, neither will give in. Instead, they push against each other, causing the crust to buckle and fold, much like a rug when you push it from both ends. This buckling and folding is how mountain ranges are born. Think about the Himalayas, including Mount Everest, the world's highest peak. This majestic range was formed over millions of years as the Indian plate pushed against the Eurasian plate. Or consider the Andes, the longest continental mountain range in the world, a result of the Nazca plate subducting beneath the South American plate. Yet the creation of a mountain is not a one-time event. As the plates continue to move, they apply constant pressure, causing the mountains to rise a little bit more each year. At the same time, erosion works to wear them down, a battle between creation and destruction that shapes the world as we know it. But the story doesn't end there. After their birth, mountains continue to change. From their dramatic birth to their continued evolution, the life of a mountain is a testament to the dynamic, ever-changing nature of our planet. After their dramatic birth, mountains are shaped by the relentless forces of weather and time. But what does this mean? Well, it's all about the processes of weathering and erosion. Let's first talk about weathering. This process involves the breaking down of rocks and minerals on the mountain's surface by elements such as rain, wind, and temperature changes. There are two main types of weathering: physical and chemical. Physical weathering is caused by the effects of changing temperature on rocks, causing the rock to crack. Chemical weathering involves the interaction between the minerals in the rock and the atmosphere, resulting in changes in the chemical composition of the rock. Next, we have erosion. This is the process that transports the weathered material down the slopes of the mountain. The agents of erosion include water, wind, ice, and gravity. Each of these forces plays a unique role in shaping the mountains. Water, for instance, can carve deep valleys and gorges in the mountain, creating spectacular landscapes. Wind, although not as powerful as water, can still cause significant erosion, especially in dry, arid regions. Ice, on the other hand, is a potent force of erosion in colder climates. As it moves down the mountain, it plucks rocks from the ground, sculpting the mountain's surface. And finally, gravity. Gravity pulls everything downward, causing landslides and rockfalls, which further shape the mountains. These processes of weathering and erosion work together, continually shaping and reshaping the mountains. They give mountains their unique features: the towering peaks, the steep cliffs, the deep valleys. Each mountain tells a story of its journey through time, a testament to the powerful forces of nature. However, it's important to remember that this is a slow process. It takes millions of years for mountains to form and be shaped to the forms we see today. The mountains we see today have been molded over extensive periods, shaped by countless storms, freezing winters, scorching summers, and the relentless push and pull of the Earth's crust. So mountains are not static but dynamic structures that evolve over time. Now that we've journeyed through the life of a mountain, let's summarize this epic tale. The formation of mountains, such as those found in beautiful Nepal, is a grand story that unfolds over millions of years. It all begins beneath the surface of the Earth in the restless world of tectonic plates. These gigantic slabs of the Earth's crust are always on the move, albeit at a pace slower than the growth of your fingernails. But even at this slow pace, the effects of their movement are monumental. As they drift, they often collide with each other. Imagine two cars in a head-on collision, the front ends crumpling upwards in response. This is essentially what happens when tectonic plates collide. The material at the collision point has nowhere to go but up, resulting in the formation of mountain ranges. However, the story doesn't end there. Once formed, these mountains are subjected to the relentless forces of weathering and erosion. Rain, wind, ice, and even the humble actions of plants and animals all play a part in shaping these towering landforms. Over time, sharp, jagged peaks are smoothed into rounded summits, and deep valleys are carved into the mountainsides. While this process may seem destructive, it's actually a vital part of the mountain's life cycle. The eroded material doesn't just disappear. It's transported by rivers and wind to other areas, where it contributes to the formation of new landforms such as plains and deltas. It's a never-ending cycle of creation and transformation. But remember, all of this doesn't happen overnight. The formation and shaping of mountains is a process that takes millions of years. It's a testament to the incredible power and patience of Mother Nature. So the next time you gaze upon a mountain, remember the incredible journey it has taken to stand before you.